Welcome to your notes on angles of elevation and depression. An angle of elevation is the angle formed by the horizontal line and the line of sight to an object above it. So essentially, angles of elevation are when you look up, and angles of depression are when you look down. So if we look at the first example, and we want to identify all the angles of elevation or depression. If we start with the person in the balloon, if they look up, then they would create angle 2, so this is elevation. If they looked down, then they would form angle 3, and that's depression. If our point of reference is the bird is looking down, so angle 1 is a depression, angle of depression. And then finally, if there's a person on the ground and they look up, that would create angle 4, so that's an angle of elevation. All right, now that we have the vocabulary squared away, let's do a couple of examples. So a meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location. To the nearest meter, how high above the ground is the balloon? So we have our meteorologist right here. He's on the ground and he's looking up. It says angle of elevation, so we know that he's looking up. He's looking up at an angle of 41 degrees. We know that we have a balloon here, and the balloon is 1,503 meters from his location. And then we want to know how high above the ground the balloon is. So that's x. Based on the 41 degrees that we were given, we have the opposite side and the hypotenuse. So we'll use the sine function. Say the sine of 41 degrees is equal to x over 1,503. So x equals 1,503 times the sine of 41, which gives us 986.06 meters. We want to round to the nearest meter, so 986 meters. Zooming in on our second example, we want to approach runway 17 of the airport, and the pilot must begin a 3-degree descent from a height of 2,174 feet above sea level. So this is 2,174. Okay, so if we look at the next example, we see that the pilot has a 3-degree descent, and he's starting at a height of 2,714 feet above sea level. So here's the sea. The airport is 1,007 feet above sea level. So that means that the smaller piece on our triangle, right here, this side, will be 2,714 minus 1,007, also known as 1,707 feet. And we want to know how far from the runway is the airplane. So that's this distance here. So we'll call that x. And based on what we remember about parallel lines and transversals, we know that the angle right there is 3 degrees. So if we were to redraw our triangle based on the information that we were given, this is 1,077, we don't know that, and that's 3 degrees. So based on the angle, we're given the opposite side and the hypotenuse. So we'll use the sine function, and we'll say the sine of 3 degrees equals 1,707 over x. We'll multiply and divide and get that x equals 1707 over the sine of 3 degrees. Enter that into the calculator, and we'll get 32,616.2 feet. And we were directed to round to the nearest tenth. Looking at our next set of examples, we see that a couple is taking a balloon ride. And if we read through the problem, then the picture that we'll create is here's our balloon. It's got a basket or whatever. Okay. And they measure the angle of depression, so down to the ground. At 16 degrees. They're 180 feet above the ground because our ground is here. And we want to find the distance from the balloon to its launch place. So that's x. Based on the 16-degree angle, we'll use our sine function. Say the sine of 16 degrees equals 180 over x. So x equals 180 over the sine of 16, which gives us 653.03 feet. Because we weren't directed to round it to any specific place, we'll just default to the nearest hundredth. In the next example, take a moment to read it, and then realize that the surveyor is 300 feet from the base of an apartment building. The angle of elevation looking up is 24 degrees, and her angle measuring device is 5 feet above the ground. We want to find the height of the building. Excuse me. So we'll find x, but then we'll have to include the fact that the ground's down here. This time we're given the opposite side and the adjacent side, so we'll say tangent of 24 degrees is equal to x over 300. So we get that x equals 133.57, but then we have to add the 5 of the device. The height of the building is 138.57 feet. Okay, in example number 3, your friend is flying a kite. She lets out 105 feet of string. So here's our kite, this little tail. It's 105 feet. Angle of elevation, looking up, is 48 degrees. We want to find the height to the ground. So we'll use the sine function. And we'll get that x equals 78 feet. All right, looking at the last two examples. In example number 4, we see that, actually move it over so we can see it a little bit better. Okay, in example number 4, we see that two office buildings are 100 feet apart. From the edge of the shorter building, the angle of elevation is 28 degrees, and the angle of depression is 42 degrees. And we want to find out how tall each building is. So we'll call this x and that y. If we can find y, then we can find the height of the shorter building. If we can find x, we can add x and y to get the height of the taller building. So we remember that this is 100 degrees, or excuse me, 100 feet, because it's the same distance as it is on the ground, which means that in each case we'll be using the tangent function. We'll say the tangent of 28 degrees is equal to x over 100. And the tangent of 42 degrees is equal to y over 100. That means that x is 53.2 feet and y equals 90.0 feet. We're going to round to the nearest foot. So our small building is 90 feet and the large is 53 plus 90, also known as 143 feet. Okay, last example. We have a plane flying at 1,000 feet or 10,000 feet, and it spots a hot air balloon in the distance. The balloon is 9,000 feet above the ground. So here's our plane, and it sees a balloon. So since the plane is 10,000 feet and the balloon is 9,000 feet, the plane is essentially 1,000 feet higher in the air, and the angle of depression is 30 degrees. We want to find the distance from the plane to the balloon, so that distance there. Based on the angle, we have the opposite and the hypotenuse, so we'll say that the sine of 30 degrees equals 1,000 over x, multiply and divide 1,000 over the sine of 30 degrees, and we get that x is 2,000 feet. All right, let me know if you have any questions.